Hey class, welcome back to the lesson on the surface area of prisms and cylinders. If you have not yet watched the previous video about using nets, stop now, go watch that, at least get comfortable with that, and then come back to this one because now we're going to use formulas. So let's take a quick refresher, shall we? In the previous lesson, or the previous video, we discussed what's going on with lateral area, area around the side, and surface area, total area around everything. We discussed what the formulas look like and what they meant. So we look at the formula for lateral area, even though it says pH, what we're thinking is perimeter of the base times the height. And then when we look at the formula for surface area, and we see LA plus 2 capital B, this is what we're thinking. It's the lateral area plus 2 times the area of the base. That is incredibly important. So now what we're going to do is find surface area, not with nets like in the last video, but with formulas. So let's take a look at our first problem that we're going to have. We have diagrams to show what's going on with lateral area and surface area. I'll reference those. So the question is, what is the surface area of this prism? This is a right triangular prism. And what is the surface area? And so we're looking for surface area, and we're going to reference the formula for surface area. And we look at surface area. The formula says the lateral area plus 2 times the area of the base. Now, we see how things unfold. But we need a lateral area in order to find the surface area. So we take a step back. How are we going to find lateral area? Oh my goodness. We look for lateral area. And the formula to find lateral area is the perimeter of the base times the height. Okay, so that's what we're going to find first. So the first thing we need is our lateral area. And the lateral area is found by finding the perimeter of the base times the height. And so we look at our figure, and we see that we have a base that is a right triangle. Hopefully you can see that the perimeter of the base is a right triangle with one leg 3 centimeters, the other leg 4 centimeters. In order to find perimeter, we're going to need to know the other side, in this case the hypotenuse. So how are we going to find our hypotenuse? Hopefully you have found it already. If you have not found this hypotenuse already, you haven't been paying too much attention to other things, so I'll help you. Here we have a right triangle, so we can use Pythagorean Theorem to find our hypotenuse. So in this case, it's 4 squared plus 3 squared will give you the square of the hypotenuse, or you will discover that the hypotenuse length is 5 because of the Pythagorean triple of a 3, 4, 5. So we've now found the hypotenuse of our base. We can now find the perimeter of the base. And the perimeter of the base, of course, is going to be 3 plus 4 plus 5. Better known as 12, right? Why did that take me a second? So the perimeter of our base is 12 centimeters. We have now found the perimeter of our base. So the lowercase p is 12. All we need now is the height. So we look at our prism. We can see the height is given as 6. That is our height. Well, that's convenient. So we have our height is 6 centimeters. So therefore, lateral area will be the perimeter of the base, which is 12, times the height, which is 6. So our lateral area will give us 72 centimeters squared. Okay, we now have found our lateral area. That's the way around the side. Okay, but the question is the surface area. So we go back to surface area. And we see that the surface area is the lateral area plus 2 times the area of the base. We need the area of the base. So to find surface area, which is, again, the lateral area plus 2 times the area of the base, we're going to need the area of the base. And the base has not changed. It's still a right triangle with legs 3 and 4. Yes, we know the hypotenuse is 5, but we have to figure how are we going to find the area of the base. So the area of the base, that capital B, it is a triangle, is 1/2 base of the triangle times the height. So when we look at this particular right triangle, we're going to find its area by multiplying 1/2 times 4 times 3, or 1/2 of 12, which is, of course, 6. Okay, so in this case, it will be 6 centimeters squared. That is the area of the base. So we have found our area of the base. So if surface area is a lateral area plus 2 times the area of the base, we know our lateral area is what we have found in the previous step. It's 72 square centimeters. We know that the area of the base is 6 square centimeters. I should put my squares. That means 2 times the area of the base is 12 square centimeters. So we're going to use our 2 times the area of the base. We're going to use our lateral area, and then we can find the surface area of our figure. Okay, so this is in an opposition of making a net. We could do this. So our surface area is equal to the lateral area plus 2 times the area of the base. Keep repeating that, by the way. It'll help you remember it. So the lateral area was 72 square centimeters. 2 times the area of the base was 12 square centimeters. And so we have now found our surface area, which comes out to 84 square centimeters. And that is how we use our formula. Okay? So let's take another practice example. And this will tell you that, by the way, this diagram just helped to show the difference of what's going on. So let's do another example. But this time, not so easy. Not so easy. Now we're going to find the surface area of the prism at the right. Here's our prism. The challenge with the prism is that we need to know what is the base and what is the side. Okay, so this particular diagram, the way it's written, will have gravity mess with you. We want to see that our bases are going to be the hexagon. Okay, so the hexagon is our base. And that, my friends, is the challenge. Because this problem is going to get a little nutty. So you got to remember the hexagon is the base. Now, why is that nutty? Because we go to surface area. So what is the formula for surface area? Remember, it is the lateral area plus 2 times the area of the base. This brings up 2 particular issues. Number 1, the area of the base. We have a regular hexagon. Ruh-roh! How do we know it's regular? Because it's given with the congruent sides and congruent angles. So it's a regular hexagon. We have to remember the previous unit. And then we also need lateral area. So let's begin with lateral area. We'll get to review momentarily. Remember what lateral area is. Lateral area is the perimeter of the base times the height. And remember, the base is our hexagon, right? Right. So the base is the hexagon. So how is this going to work? We need to find the perimeter of the base times the height. Now, each side of the base is 6 centimeters. There are 6 sides, so we know the perimeter of the base is 6 sides times 6 meters. That gives us a perimeter of 36 meters. Yay! The height of this, remember, don't let gravity mess with you. If the hexagon is the base, the height will then be 12. Okay, so 12 meters will be our height. So we're going to keep that in mind. So our height is 12 meters. So that means the lateral area is going to be our perimeter of the base times the height. So our lateral area is going to be, you know, a little bit of a number. Punch that in your calculator, beep, boop, beep, and you get 432 square meters. So we know our lateral area is, what did I say, 432? I did, okay. 432 square meters. That is our lateral area. The lateral area is just around the side. Now when we get the surface area, now we know the lateral area, 432, we need to find 2 times the area of the base. We need to find the area of the base. Do you remember how to find the area of a regular hexagon? So let's take a look at some review. The area of any regular polygon, by the way, is 1/2 the apothem times the perimeter. Woo! So hopefully you remember that. 1/2 the apothem times the perimeter. What is the apothem? Do you remember that the apothem is from the center to the side? That's our apothem. So how are we going to find that? Remember the pop-out triangle. So we can make a right pop-out triangle. And we remember how the pop-out triangle works. From the pop-out triangle, we have the half side, which is the short leg. We have the apothem is our long leg. And we have 1/2 of the vertex angle that is tucked in here. Now remember, we're dealing with a hexagon. So how do we find this particular angle? It's 360 divided by 6 to give us our vertex angle. And then we end up with 60. And then we take half of that to give us our angle in here, 30. So we're again dealing with a 30, 60, 90 triangle. Now, since one whole side length is 6, half the side length is going to be 3. So this will be 3 meters here. Since it's 3 meters here, we have a 30-degree angle. 3 meters is our short leg. That means our long leg in the 30, 60, 90. Hopefully you remember 30, 60, 90 triangle. Quick review. We have a short leg of 1. The hypotenuse is 2. The long leg is the square root of 3. That's our 30, 60, 90 triangle. So our long leg is the short leg times the square root of 3. That means our apothem is 3 times the square root of 3. So we have found our apothem, 3 times the square root of 3. So in our formula for the area of the base, the apothem is 3 times the square root of 3. All we need now is the perimeter, which we have found previously at 36 meters. So when we find the area of the base, okay, we find the area of the base, or the capital B, okay, the area of the base is going to be 1/2 times the apothem times the perimeter. Okay, so we have now found the area of the base. Okay, we can multiply that out, and then we end up with 93.53. Okay, we'll get to that in a second. So you multiply all that on your calculator. In the case you forgot, I'll show you real quick. So we multiply our numerators 3 times the square root of 3, 3 square root, equals, then times 36, equals, and then divide by 2, equals. So we have 93.53. Okay, so hopefully you remember how to do that. So we have found the area of the base. Now why is that important? Because we're finding surface area, which is the lateral area plus 2 times the area of the base. So our surface area is equal to the lateral area plus 2 times the perimeter of the base. So the lateral area, remember, was 432 square units, if I can write that correctly, plus 2 times the area of the base that we just found. Okay, so trigonometry comes back, regular polygons come back, all this sort of stuff comes back. So we can just, from here is calculator work. 432 plus whatever number that is, about 187. And so we get our total area of 619 square units, in this case, meters. It says round to the nearest whole number, so we are set, right? Round to the nearest whole number, round to the nearest whole number. That is how we find surface area. That's how we use our formula. So we'll come back and wrap up this lesson with cylinders next, but the concepts remain the same. So hopefully you learned something. See you later.